All right, let's get started. So, game plan for today, we're going to finish up our discussion about input-output streams, and then we're going to do simp IO first, and then we'll talk about modern C++ types. File streams you learned in 106B already, so we're not going to go over that, okay? But file streams work pretty similarly to input-output streams. We'll briefly discuss the differences. Okay, so just as a brief recap, last week we used string streams to be able to parse strings and split them up into different tokens. So for example, we learned about the output string stream. And then we were able to use the power of the string stream to be able to convert between the string type and to any other type we want. So in this example, we tried to convert different tokens within str into an int type. Okay, everyone, is this familiar from last week? Yes? All right, any questions about this right now? This is pretty much the code we wrote last week. The only difference, last time we had two if statements. This time I just combined the two if statements into one, and without a informative error message. All right, awesome. Yeah, so get integer. We did not get to this point. Okay, so let's talk about this code. So this is the code which is written here. Okay. Written down inside here. Bad welcome program. So I want you to try running bad welcome program. Try running it in your main, and all right. So try running this function and just play around with it. See what you get. Okay, so I guess everyone's playing around with this function. You can have a pretty good idea of it. What does it do? It asks you for your name, asks you for your age. It prints hello, name with a given age. Do you want to try again? You type in something, it tells you what you said. Okay, there's no reprompting here. This is just a simple program. Now, the code for that is written down over here. Cin, you read into a name, which is a string. Cin, you read in age, which is an int. Then we just print out the name and the age. In this example, I added an extra space. And then cin response to read in the response. Okay? So just as a quick example, suppose, let's try to run through how cin and cout work. So cin and cout, they're kind of like input string streams with one major difference, which is when you try to read in more tokens, if there are no tokens left in the buffer, in other words, if you attempt reading and it shows EOF, then what cin does is it kind of stalls the entire program and it waits for the user to type in something. Okay? So when you ask for cin arrow name, there's nothing in the cin buffer, which is why when you tried running it on your program, the program kind of froze and it waited for you to type in something. Right? Did everyone experience that? The program freezes, and then you can type in something on your keyboard, right? Just as a explicit demonstration of that. Yeah, notice here that we haven't printed everything else. It said, what is your name? And it paused over here because it's waiting for the user to type in something. So if I type in Avery, okay, then it moves to the next stage where we typed in Avery. And remember, when you type in Avery and you press the enter button, it also includes that new line character into the buffer. Once it's able to read in something into the buffer, then it tries reading in one token. So it reads in one token over here. It does not read up to the white space. It just reads until it reaches a white space. Okay? On future cin operations, they skip the white space, and then it tries reading in more. So here, on this call, it first skips the initial white space. It notices, oh, there's nothing left. EOF is on. And then it's able to prompt the user for another token. So here, and that's why it now prompts you for age. Okay, does this make sense so far? Okay, does the prompting versus the buffer, does that all make sense to you? Any questions so far? All right, yeah, the important thing to note is that the extraction operator it skips any leading white spaces and it reads up to the white space, but it doesn't consume the next white space. Okay, so here, cin reads up to the white space, but it doesn't consume the white space. It's only when you call cin another time, then it skips the white space and it tries to read the token. Okay? This will become later when we get to common cin bugs. So suppose I typed in 20, then it's able to read in 20, and it realizes it's an int, so it successfully converts the age to 20. Then when you're able to print out out name and age, it's able to print my name and 20. When it reaches cin with response, the buffer is empty, so it is able to prompt the user for another response. So you type in yes or something. Okay? Key takeaways. Let's see. Let's go through the key takeaways. When does the program prompt the user for input? Candy? Yes?
Wait, why is that a bad welcome program? What's wrong with it?
We will see on the very next slide. Yes. But yeah, that is a very bad welcome program. Okay, so let's just do a quick recap. When does the program prompt the user for input? Yes. When what happens to cin specifically? So cin is prompted when there's nothing left in the buffer, right? That's when it is able to ask the user for more. All right. Why does the set operation not immediately print? We can skip that. Does the position pointer skip? Does the position pointer skip the white space before the token or after the token? Before or after? After. The position skips the white. It skips the token before, right? So in this example, if you type in anything in, like once you type in, it's only on this operation when it's able to skip the white space, right? But when you type in something else, when cin tries to extract the age, it reads up to the white space, but it doesn't consume the white space. It's only on the next operation it's only on the next cin operation when it's consumed. Okay? Just a minor detail that will become a source of bugs later. Cool. Let's skip these. Now, let's try to understand why it's a bad input program. In fact, I want you to try it out. Try typing in stuff to make the program fail. Okay? So an obvious one is, okay, well, instead of typing in an age, type in some random thing that's not a number. That fails. Is there any other way you can make the program fail? Empty string. Okay, so the empty string, yeah, if you type in the empty string, the buffer is still empty, so nothing is happening. Okay, great. Any other ways to make the program fail? Here's one way. I'm going to type in my full name. Okay, now, watch what happens. All right, to the person next to you, go through this output and try to explain, like, don't try to explain why yet, just try to explain exactly what symptoms do you see. Go. All right, so step by step. What's the very first symptom you notice from the very top?
They didn't ask for age input.
Okay, so notice that I typed in my full name and then it just completely skipped to the end, right? The program did not ever ask what my age was. Okay, it did ask what my age was, but it doesn't ever prompt me to type in my age. It does ask, do you want to try again? But it never prompted me to type in anything. Okay? Anything else? Any other symptoms? Yeah, so we never typed in any age, but it just thought age was 0. Okay, so that's kind of odd. Anything else? There's one more. One more odd thing you notice about this program. Yes?
I jumped forward to do you want to try again, you said, without...
Right. So it basically skipped all the other cin calls. Okay? Interesting. Yes?
It doesn't include Wang when it says hello.
Yeah. So yeah, that's the very last point, which is when I typed in my full name, it only read the first part of my name. Okay? And to get like a visualization of why that's the case, I made a nice little animation here. Okay? So cin tries to read in a name. There's nothing in the buffer, so we type in my full name. Okay. At this point, what does cin read in? Until Avery. Why until Avery? Exactly. So it reads up to the white space, but it doesn't. It reads up to the white space, doesn't consume the white space. So everything else after that space is just left in the buffer. Okay. So that's why in the name variable you only see Avery. All right. Cin tries to read an age, so it goes to it consumes the leading white space. What happens when it tries to read an int? Sorry. Awesome. So the buffer is not empty. So the program does not stop to ask you for input. Okay? When it tries to read in an int, what happens? Not an int. And remember last week, if you try reading an int but you can't read an int, what happens? The fail bit is turned on, right? Yeah, so here, it fails to read an int, so the fail bit is turned on. Okay, now when you try to read in name something age, it's able to print out the name, Avery. Age is not like an initialized variable, so it could print anything. In that case, it printed 0. It could literally print anything. Okay? Okay, and then the last line, what happens here? Dang it, my answer is here. Don't look at the answer. Okay, buffer is not empty, so the user is never prompted. Is it able to successfully read a response? Because if you think about it, technically response is a string, right? That's a string over there. So why can't it read the string?
Because of the fail bit.
Right, the fail bit is turned on. All right, so when the fail bit or the EOF bit is turned on, all future operations are frozen. Okay? So my summary slide, why cin combined with the extraction operator is a nightmare. One, cin, if you type in a full line, it puts a full line into the buffer. But when you try extracting stuff, it only extracts token by token. So even if you type in Avery Wang, the thing it extracts into your token is Avery. Second, if you type in more than one token, and if you don't actively think about what's left in the buffer, that trash in the buffer will make cin not prompt the user at the right time. Right? Here, we wanted to have cin prompt the user again, but because there's still stuff left in the buffer, cin is never prompted again. And then lastly, when cin fails, it just kind of gives up, and then anytime you use cin, that fails as well. Okay? So if you've ever tried to use cin in your own programs, you'll pretty much find that if you try testing erroneous input, basically cin just kind of freezes for the rest of the program. Okay? So let's try to implement simple I/O. And the idea we want to do for simple I/O is instead of doing something like this, let's see, where did the program go? Here. Bad welcome program. Okay, now there is something that you learned in CS 106B on Friday, which can help us get rid of one of the problems. So there were 3 problems, right? It only reads token by token. What was the second problem? Trash in the buffer will not prompt the user at the right time, and then when cin fails, all future operations fail too. You did learn something in 106B which can help us solve some of these problems. In 106b, you use the file streams, and you learned that one way to read input was through the extraction operator, right?
I don't think we've learned that yet.
Keith didn't cover streams?
No.
Keith didn't cover streams. Okay, well, too bad. So then, the idea is this reads line by line, token by token, but there is a way to essentially extract an entire line. Okay? Has Keith introduced getLine? What did he teach on Friday?
He's only covered for token this.
Okay, because Friday's lecture does say streams and strings, so that's odd. He just changed it? Is he ever going to cover streams? Okay, well, that's too bad. Basically, there is another function called getLine, which lets you read in an entire line. Okay? So instead of using this extraction operator, you can read an entire line, which reads up to the next new line character. Okay, so let's suppose we put this in. Okay, so that would solve this problem because, let's see. Yeah, if we tried replacing the first one with, and if I type in my full name, okay, I can still type in my age, and then it's able to read in my full name. Okay, let's just quickly process what does that mean in terms of the animation. What is Keith doing? Okay, so I don't have an animation for that, unfortunately. But basically, the getLine reads up to the next white space character. It reads up to the new line character, so it's able to move the entire. It consumes the entire new line in the buffer. All right, question? Yeah.
So in comparison with CIN, when you were going through the tokens, you said that CIN goes up to the white space character, but doesn't consume it. When does that white space character actually get consumed?
So when you use the extraction operator, it reads up to the next white space, but it doesn't consume the white space. When you call the extraction operator again, it skips all leading white spaces, reads the token, and stops at the next white space. Okay? You bring up a good point, which is, what does getLine do? getLine reads up to the next new line character, and it also consumes the new line character. Okay? Can you imagine how if you mix those two together, you'll get weird things going on? Do I have an example? I have an example at the very end, so I'll get back to that. Okay? Cool. All right, so let's, so we're able to fix this line, and we're able to fix this line down here. Do you want a response? Okay, just get the entire response in there. Okay, any questions at this point? Yes?
Do we need to include anything for using getLine? Because I'm getting an error using unpicked get.
Is this from this code?
Yeah.
I think getLine is in all of these.
It's an IO stream.
It's an IO stream, right? Okay. Yeah, because I'm pretty sure I included IO stream at the very top. So can you double check that? Okay. Are you using getLine lowercase? So getLine. getLine like lowercase getLine. Okay. And then for the parameters, make sure you pass in. Make sure you pass in the stream, so CIN, and then you also pass in some variable, which is like a reference. It's a reference variable. Whatever getLine reads, it is gonna put whatever it reads into that variable. Okay. Yeah, it's kind of odd. Some people think getLine is supposed to return what it read, but it actually puts whatever it read into the response. Okay. Any guesses what getLine's return value is? Yeah. Yeah, pretty much. It does the same thing as the extraction operator. The extraction operator returns the stream, which is implicitly converted to a Boolean about whether or not it succeeded. All right. Cool. All right. So we're able to fix this, but the issue is we still can't fix this line because this line we're trying to read in an int. All right, but we're not able to do that directly. So here's where we're going to try to read our we're going to try to use our function getInteger. Okay, we're going to implement get integer. Okay, Keith went over what get integer was, right? The function get integer? Yes, I'm fairly sure he did. Yeah, so the get integer prototype looks something like this. And then I think it also, you pass in a string prompt. Okay, is this vaguely familiar? There's a prompt, you call get integer, you can read from the user. Okay, so one simple attempt to implement get integer is simply just use what we wrote last time, right? Last time we wrote, what did we write last time? We wrote string to integer. So what you could do is you could do something like, read a line from cin, string line, read a line from cin, and then turn it into an integer. So remember how we turned things into integers? We used a string stream, right? We used an iString stream. We converted the line into, we put that line into iString stream. And then how do you read an int? Int val, right? And then you just do ISS val. Okay, so this is basically using what we wrote last time, string to integer, and we're just pulling whatever is in that line and reading directly into ISS. Okay, what are the problems with this again? Same problems we reached last time.
Val might not, ISS might not have integer at the beginning, and there might be some at the end.
Right, so when the user does not type in an integer, this would fail. Okay, so kind of like what we did last time where we tried fixing that using state bits. Let's copy that code in here. So I'm just going to copy the entire code from here into here. We're going to change this for sure. Okay, this is the code we wrote last time. And instead of S, so this is the code we wrote last time. And then if you try to combine that code, you'll get something like this. Right? You print the prompt, you try reading in the token, convert it to a string stream, try getting an integer out of that. If it fails, reprompt. Okay, one way to reprompt is to use recursion, right? But you don't want to do that. The better way is to use a while loop to be able to reprompt. Make sense? All right, what questions do you have right now?
Why do you not want to use recursion?
Oh yeah, so just in general, don't use recursion unless the problem is like inherently self-similar. So you'll sometimes see students write something like this. This will be covered more in 106B, but don't use recursion unless the problem you're solving is inherently like a self-similar problem. So getting integer, it's not really like a self-similar problem. It's not like the ones you learned in class, factorial. So yeah, basically whenever there's a simpler way of solving it, try to use loops instead.
You can also think about it as, in this case, you're not really breaking down the problem into smaller pieces. You're really just redoing the exact same thing every time. So that might make you think more of like a loop, a while loop, rather than a recursion, which is more like breaking things down into smaller and smaller pieces.
All right. So yeah, and then the final thing we have to worry about is we already mentioned get line, but when you read cin and you try to reading in a token, that does not read the entire line. That only reads the first white space caret token. So you fix that by replacing it with get line. Okay? Now, I want you to spend 2 minutes, just talk to the person next to you and try to go over what was written over here. Okay? Try to explain each line and try to understand why each line is necessary. Okay? Go ahead.
So first it's displays the
All right, while you're still talking, are there any questions right now? What are your questions?
What's the double ampersand in the if statement?
Oh, the double ampersand. That's just logical and. So we're gonna try reading in result. If that fails, then because this is an and, so if one of these fails, then you skip the second one,
Right.
and then you just if you skip the entire thing, then the return statement doesn't run, and you go back to the top of the loop again. Yeah. If this succeeds, then the first part is true. So you try the second part, and you want to make sure that ISS cannot read in any more trash. If it's able to read trash, that means there's something after the integer, that's not a valid integer. So you don't want to read pump as well. Only if both of those are correct can you return. All right. Any other questions? All right. So, I think, is there anything else we have to go over here? Your question? Yeah.
So do you not need a bracket if there's only one line for if statement?
Bracket, if there's only one line? Oh, that's a good question. I think you might need the bracket. Okay, I don't quite remember what the order of operations are, but...
What's the question?
Oh, do you need a bracket around you? I don't think so.
No.
I don't think so, yeah. Yeah, because by some order of operations, I think this one is higher than this one.
Yeah.
Yeah. Logical and is pretty low on the list. That being said, feel free to put the bracket in there for clarity as well. Cool. Well, let's just run through this once. So suppose I typed in 20 lol. All right. So the get line reads in 20 lol into line down there. The ISS, we're going to convert the 20 lol into an input string stream. And then you try to reading into result. So you read in 20. That succeeds, so then you try to reading in trash. You read the L. The fact that you're able to read another character means that whatever the user typed in is not valid. So we skip the return statement and we try again. Okay, let's say user types in something else, negative 2013. Get line reads the entire line, including the new line character, into the variable. We convert it to a string stream. You try reading in a result. Then you try reading in a trash. There's no trash left, so this second operation fails. So this thing returns false. If you negate it, you get true. Because both of these are true, you return the result. Okay? Does that help? Question, yes?
Bit of a syntax question, but why are you allowed to omit the open brackets after the if statement?
Oh, okay. So why are you allowed to omit the open brackets there? So in C++ and in Java, and in some languages, if your if you don't put brackets there, then it just assumes your very next line is that line specifically for the if statement. Yeah. Now, for style-wise, don't do this. Because if you want to add more stuff to the if statement, some people might accidentally just write it underneath here, and then the if statement doesn't work. So when in doubt, put the braces in there. Yeah, I'm just doing this because it's short. Normally, in most cases, if you have an if statement that is really short, like if this return true, then you can just put it on one line. Yeah. When you do recursion, I think it's really nice to do if the string is empty, return empty string directly. When you don't have that much to do.
Yeah, and just to emphasize, this only works when your if clause is one line long. Even say if you wrote everything on one line, but there's semicolons in between, it's really multiple lines, and that won't work. But it's not affected by spacing. It's affected by the number of statements in it. And one really common error you might see when you don't put braces around is say you were trying to debug this, and you put in like a cout statement to try and debug it, and you forget to then add in the braces here. You'll suddenly be, oh wait, why is this suddenly working completely differently than I expected?
Question, yes?
And is throwing the domain error part of, is that syntax a part of the simple IL?
Yeah, so that's a good question. So, but whenever you do an operation which is reading in from C in, you generally want to check the return value to see if it succeeded. Now the question is, when would get line fail? You know cin, the extraction fails if the types don't match. When would getLine fail? GetLine reads a string. How could that fail?
There's nothing in the
If the user types in nothing, then technically what the getLine, it gives you the empty string. So that's fine. It's a good guess though. Yeah, this is a pretty tough statement. It actually, do I want to go into this? I'll let you try random things and see if you can get getLine to fail. Yeah, it's actually really hard for getLine to fail, but there is one instance where getLine can fail. All right, but in general, you want to check the return value just to make sure that that nothing is returned. One reason could be cin is failing somewhere else. If you have like a program running many things at once, cin could be used somewhere else, and if that fails, then this getLine would also fail. Right? If cin had some fail bit turned on, then this line would not work. Okay. In the context of this problem itself, cin will always work because cin is not used anywhere else. All right, we're almost done. Let's just, so this is the full implementation with reprompting. This is the hardest function to write in the standard libraries. So you've just managed to write the hardest function. Super useful for assignment 1. Just an FYI. All right, final stream gotcha. I kind of alluded to this before, but if you mix a extraction operator with a getLine, weird things happen because when you try to read using the extraction operator, it reads up to the white space, but it doesn't skip the white space. Well, actually, there's a little bug on this slide, actually. Okay, let's change the example. Remove ounces. Let me just write the example here. Okay, so suppose we had this example. Here's an example of when that bug might manifest itself. We have a string stream. Let's call it, let's give it 16.9, followed by a new line character, followed by 24. Okay, so if I try reading in a double value, ISS val, what does ISS arrow val give me? Val is 16.9. Okay. When this is done, where is the pointer, the position pointer?
before the white space.
It's before the white space. Okay, because it doesn't skip the white space afterwards. Suppose I try to do a getLine here. So getLine ISS with let's say string line. What is line? Yeah, line is the empty string. Right? Because the position pointer is technically right before the new line character. So if you try to read, using getLine reads up to the new line character and consumes it. Right? So if you try to read getLine from here, it's just going to read up to the new line character, consume it, and then be done. So line here would give you this, which is not exactly what you wanted, right? Okay, make sense? So when Keith finally teaches streams, he'll explain how you don't want to mix the extraction operator with getLine. There is a fix to this, which I'll show in 2 seconds. Yes?
What if you call getLine one more time?
Yeah, if you call getLine one more time, by this point, the position pointer has skipped past the new line character. So if you call getLine here one more time, then you'll get the right answer. So line is equal to 24.
How does it know to stop even though there's no new line character?
Yeah, getLine reads up to a new line character or to the end of the buffer. Yeah. Question, yeah?
Would line return 24 or space 24?
It would return, it's a good question. It would return space 24 because the extraction operator skips initial white spaces, then it reads the next token without skipping the next white space. getLine does kind of the opposite. getLine reads all the way up to the, it starts wherever it starts and it goes up to the new line character. It consumes the new line character and then it takes whatever was before the new line character as the new line. So in this case, the white space would be included. Good question. Anything else? Yeah, there's a little bug into the slides. It should read up to the white space, the new line character. Yeah, and then the simple fix to that is you can actually just have the stream move forward by one character. So you can do ISS.ignore. That ignores one character. So when we're done with the 16.9, we ignore one character, so we skip the white space. And then finally, when the getLine is run here, this would give you space 24. And we wouldn't need this one. Make sense? Okay, this is a very common bug, okay? I guarantee a post on Piazza in 106b will appear, which is, why doesn't this work? I'm using all the constructs correctly, and the reason is you're not supposed to mix the new line character with get line, unless you think about it carefully and you skip the right characters. Okay, cool. All right, your challenge for Thursday. So this is your challenge. Write the function prompt user for file. Also helpful for assignment 1, and this is also a really important Stanford library function. I don't think assignment 1 for CS106b has you call this, but I'm pretty sure assignment 2 will have you call this function. Good? Awesome. All right, we have 10 minutes. Let's just quickly talk about modern C++ types. Okay, let's just quickly go over the types. So one thing about types is you'll often see this really annoying error message. Has anyone started assignment 1 in CS106b and gotten this error message?
Yeah.
Yes? Okay. What's annoying about integers in C++, also in some other languages, is that integers, they are signed, which means that they can be both positive and negative. There's also another type called an unsigned int. Those can only be non-negative. All right? Now, there are certain, like when you try asking the string what is its size, because sizes can't be negative, so it returns the type unsigned int. Okay? When you try to compare a regular int with an unsigned int, that's potentially not a good idea. So that's why you get a warning like this. Okay? Make sense? Yeah. So I just want to explain why the warning appears. Other functions which expect unsigned ints. So the dot size returns an unsigned int. When you do the bracket operation, it also expects I to be an unsigned int because you're indexing into a string. Okay? What's the fix to this? You can actually declare an unsigned int yourself. We usually use this thing called size_t, which represents a variable which represents a size. Okay, so size_t, I equals 0. This would clear all the errors, right? Because here we're comparing unsigned int, so that's fine. We're not going to go too much detail into what exactly an unsigned int is. That's CS107. But just an FYI, if you ever get errors like that, that's the reason. Do you have any questions? Yeah.
Yeah, I did want to ask about the actual byte size, size t. Is it platform dependent? Is it either 4 bytes or 8 bytes, depending on your platform?
Good question.
It depends on your platform. Pretty much always nowadays it'll be 8 bytes, but if you're using an old like 32-bit processor, then yeah, the size t will be specified in your platform.
Is it defined as the same width as long on your machine?
So they have 2 different definitions, and your machine will tell you the definitions for both. But there are some defaults which say that it varies. Some of the specifications will say that those 2 are always the same. Some will say that they differ. So you can look it up for your machine.
Yeah. Don't worry if you don't understand about what these bytes are. In CS107, it's covered extensively. All right. Quick challenge. If you ever coding challenges for like interviews for internships, this is a very common bug that you'll see. I failed coding interviews because of this. Spot the bug. So the idea of this function is basically return a string without the first character and without the last character. Anyone see the bug? Yeah.
Empty input string.
Okay, so if you put an empty input string, what's wrong?
Well, it subtracts 1 from the size, except it's unsigned. So
Right.
you're in trouble.
Yeah, because if you put the empty string in here, str.size is 0. 0 is unsigned. 0 minus 1 it's -1, but -1 is not an unsigned int. So you'll get a really weird value for that. What happens is you get a gigantic value for that, so your program crashes. Okay, just an FYI, this is a pretty common bug. Yeah, so in this case, you might want to handle the empty case separately. Cool, all right. I'm just going to quickly go through these. These are just some things to note. Type aliases are essentially, they let you give a really long type another name. We'll commonly see this when we do deal with collections. Sometimes you just have these gigantic names, and you just want to give them a shorter name. So you can just use using something equals another type, and then you can use map iterator as a alias for that really long type. Okay, pretty straightforward. When do you use this? When the type name is really long, and when you want like a common name for each type. So each of the collections that we'll be using, vector, list, all the other types, they each have well-named types. So they have a vector iterator, there's a map iterator, there's a vector reference, a map reference. The names of these types aren't actually reference, but it's just because they use a type alias to be able to name all these types so that they have similar names. Okay? Cool. Auto. This is literally Keith's like favorite C++ thing. Auto is basically a super lazy way of doing whatever it was before. Where when you use the keyword auto, the compiler will figure out the type for you. Okay? So you don't have to specify what the type is. The compiler will figure out what begin is supposed to be. All right? So just a quick test. Let's go line by line. Multiplier equals 2.4. Auto, what type is that? Double, okay. Second one, name equals the string Avery. Not quite. It's a char star. It's a C string. So, okay, at the very least, Keith covered this on Friday, right? About C strings versus regular strings. No? Oh my gosh, what is Keith doing? Okay, so in C++, there's two kinds of strings. There's a C string and there's a C++ string. If you just do the literal, that gives you a C string. Normally, when you declare string name equals Avery, it converts the C string into a C++ string for you, so you never have to worry about it. But if you ever use auto with the C string, you have to make sure you explicitly say, pass it to a string constructor so that better name one is a string. Okay? Cool. All right, I've given up at this point, but did Keith talk about const?
Oh, he did.
Oh, he did.
You did? Oh, okay, great. Great. So you all know what const is, right? Const references. So if you ever need to declare like a const or a reference, auto drops all of that. So even if your variable is a const variable, if you try to give it into an auto drops any of that. So if you want like the const to still survive, you have to put const in there. All right. What's the type of auto for copy? Auto copy equals key. It's a vector string. All right, not a const vector string. It's a vector string. What's the auto reference ref multiplier equals multiplier?
Double comes.
So multiplier is a double, and we're declaring this as a reference. So ref multiplier is a reference to a double. Okay, Keith probably didn't cover references. Never mind. Okay, and then you might wonder, okay, auto is just a lazy way of is just being lazy, right? There are actually instances where you have to use auto. So in that last one, we're going to explain what this is later. This is called a lambda function. I'm missing a semicolon here. This is called a lambda function. What's cool about a lambda function is you don't actually know what the type is. Because what happens is the compiler takes that, creates a new class, and names it something. And the problem is you don't know what the compiler is naming it. So in this case, you have to ask the compiler to give you the type for you.
And we'll be going over lambdas in a lot more detail at a later lecture, a couple weeks from now. So no worries if you don't understand what that means right now.
Yeah, we're just trying to point out that auto is actually useful in many scenarios. Yes, question?
So Avery, when you use auto name equals Avery, name would be a C string, but better name one would be a C++ string because you use string Avery. So let's say you do name plus better name one, would that give you an error?
Name.
A C and a C++.
Name plus better name one. What that would do is the plus operator will implicitly convert the C string to a C++ string. I think that's right.
So what differences what is the difference between the C string and the C++ string?
So don't want to get too deep into this, but in CS 107 you'll learn, you'll learn pointers really soon. A C string is really just a pointer to, is really like an array of characters, right? You can think of a string in its most primitive form, it's an array of of a lot of characters, okay? So in a C string is pretty much just, here's an array of characters, you deal with it. It has no methods on it whatsoever. while strings have a method to themselves. Okay. The worst part about C strings is you don't know the size of a C string. You have to actually try to figure that out. Okay. So yeah, C strings. C strings are weird. If you try to add two C strings, you'll get weird things. Yeah. So avoid C strings. Use C++ strings, especially if you're in especially when you're coding in C++.
Yeah, and in terms of programming in C++, another, I think maybe one of the most common times you'll find yourself worrying about whether something's a C string or a C++ string, normally it doesn't matter. Normally, like, almost all of the time we usually just say like string name equals quote Avery quote, and that works perfectly fine. Maybe one error that you'll sometimes see is there are occasionally functions, especially functions that are based from C, which C++ was originally written on, that only take in C strings. And so what'll happen is you'll have some sort of variable like name that you've been using for the rest of your programs, and to use just that one function, you'll have to remember to explicitly convert it back to a C string to use that as like a parameter for that function. Yeah. But yeah, normally you don't have normally you can work with both and you don't really notice them.
All right, we're almost done. We're almost out of time. But yeah, you can use auto for the return type. That's really controversial. You can also use auto. Notice you can't use auto for the parameters. Okay, and there's a special reason for why you can't use auto in the parameters. So when do you use auto? One, when you don't care what the type is. There are often cases where you just want the item. You don't really care what the specific type it is. Okay, later in 2 lectures, we'll deal with these things called iterators. There are many types of iterators, but all we care about is that it's some sort of iterator. So you can use auto in that case. All right, and then there are other circumstances where auto is really nice to use. Normally, I tell students do not use auto in CS106B because section leaders, the overwhelming majority of section leaders hate auto. Okay, but the problem is Keith really loves auto, so you're good to go. Feel free to use auto in your code. Now, some people say always use auto, like even for ints, use auto. The other camp is never use auto. Where we kind of fall in is use auto when the types are really long and when you don't really care about the type. So pretty much if it's longer than like 4 or 5 characters, feel free to use auto. But if it's like an int or a double, you don't necessarily have to use auto. It might make the code more readable. Okay? You can just Google auto when to use, and then you can find internet debates on how to use auto. Okay? Pretty controversial. Oh, the cool thing about auto is if you ever in the compiler, you can actually look at what a type is. So suppose I said I is equal to 16.9 ounces. We said that this was a C string, and you can, if you take your cursor and you put it over the auto, it will tell you what the type is. So you can see here it says const char star. Okay, that means C string. If instead I wrap it into a string constructor, then you can, if I scroll over that, you can see it says, oh, it's a string. Okay? So yeah, the reason why auto is nice now, modern compilers will tell you what the type is no matter what. So feel free to use auto. Questions? Yes?
Is that const char star different than the fact that auto gets rid of const?
String literals are weird. So yeah, string literals are weird in that they have a weird constness to them. So I don't want to get too much into that, but feel free to ask us after lecture. Yeah, because literals are weird. Later on, we'll talk about L values and R values. String literals are kind of weird. Okay? Yeah. I think we're basically done. Yeah, you can just take a look at these pairs and tuples. Have you ever wondered how do you return 2 things from a function? Python lets you do that really easily. Java does not let you do that. C++, you'd usually use a reference parameter, but there's this other thing called a pair, which lets you return pairs of values. Okay, and one of my favorite things is this thing called structured binding. It came out 2 years ago, and it basically lets you do the super convenient thing you can do in Python. In Python, you can just extract like the different components of prices into the 2 variables. Here we're doing the same thing. Auto will figure out what the type of A and B is, and it extracts the two components of prices into A and B. Okay, does that make sense? Yeah, this is called structured binding. Yes?
So is pair a type, and you give it what the template on what the type inside of the pair is?
Mm-hmm.
Okay.
Yes. Yeah. I didn't go too much detail into this. Do I have any? Oh, okay. Okay, yeah, I was trying to get rid of my slides, and I think I got rid of too many slides. Yeah, so pair is a type. Yeah, pair is a type, and it's technically a template. You can put anything inside a pair. You can put a pair of ints. You can do a pair of int and string. And if you do auto, it kind of figures everything out for you, so you don't have to worry about that. Okay? To get the first and the second components, you do dot first and dot second. If you have tuples, you do that like weird bracket thing to get the different components. Okay? Pairs are very frequently used, especially in the STL. Tuples, not so much. Structs, they're kind of like tuples. Did Keith cover structs? Probably not. Yep, probably not. Yeah, so structs are kind of the same thing, but instead of like just different components, you can actually give names to each of these components, which makes the coupon to dot expiration date more clear. Okay, these are called structures. They're variables which pack in different types into one coherent type. Okay, this is exactly what a class does as well, right? A class has different members inside of it, but a struct is essentially just a lightweight class. Structs usually don't have many methods. There's no privacy. There's no public and private in structs. It's just a bunch of variables splat out in memory. Okay?
You'll be using structs in assignment 1 for both 106B, the Welcome to C++ assignment, and for assignment 1 in this class, if you choose to do it for draft phase.
Mm-hmm. Oh, is it on 106B assignment 1?
Yeah.
Oh, wow, okay. Wait, and Keith didn't teach it?
He teaches it in the assignment.
Oh, what a typical Keith thing to do. All right, well, when you're done with assignment 1, then we can talk more, and you'll know everything I'm talking about. All right, references. I don't want to talk about that. Oh, okay. So here's this very common chart where if you want to pass in parameters, there are some general general patterns that you'll see when you pass in parameters. In C++, remember, one of the major goals is to make code as self-documenting. I forgot what the exact terminology was. You want to express intent in your code, okay? And based on what the parameter type is, you can guess what the intent is. So remember how Keith talked about const something ampersand? That's for when you have large collections, when you want to pass collections into your function, but those are just inputs, those are not outputs, in which case you pass them as const x ampersand to indicate that this is a input only. You cannot change x. As opposed to if you pass in something like this, which means whoever's calling the function should expect that x was changed. Make sense? Yeah. Remember, many times when you read code, you're only reading the headers. You're reading what the functions do. So there's no other way to document that other than through comments or by explicitly saying, this is an input-only parameter. This is a in-out parameter. You're passing in, and then you're modifying it to be passed out. All right? There's also one more thing. In CS106B in the past, they like to use out parameters as this, but now the more common one is just return the collection itself. So if you're building a collection inside the function and you're returning it, just use it as a return value. Okay? Yeah, in the past, 106B has this debate where you don't want to return large collections. Totally fine now, especially since Keith is teaching you. Yeah, one reason you might remember about why you should never, you should only use this pass by value. We talked about pass by value, right? Yeah, pass by value should only be used if it's a cheap thing to copy. So ints, doubles, those are really cheap to copy. In fact, if you're passing in a int or a double, the overhead of using a reference is much higher than just copying like 4 bytes or 8 bytes. So if you're using like really cheap things, just use pass by value. Those are simpler. If you're passing expensive collections, use the ampersand. Okay. All right. Yeah. You'll know that the pass by value creates copies. In week 7, we'll talk about moving, right? Because instead of copying stuff, can you just move stuff instead? And you'll see these more complicated ones, which we'll talk about week 7, right? This double ampersand, that's where instead of copying, you're moving. Okay, we're almost done. I mean, we don't really need these. Uniform initialization, Keith will talk about this, right? I think Keith will talk about this. Okay, maybe on like assignment 2. Probably assignment 2. So yeah, you'll learn about uniform initialization yourself as well. Everything in one example. Here's everything in one example. You can feel free to take a look at that, and we're done. So just a couple things. On Thursday, Anna will be covering the STL and sequence containers, and then Anand is covering next Tuesday, right? Do you want to do or Thursday? Okay, he can only do Tuesday. He has a section on Thursday. Yeah. Okay, we'll see. Yeah. We will have a guest lecturer coming in. He approached me and he said, "Oh, I really want to do a guest lecture for 106L." So you'll get Anand. He's the guy who, if you took CS 106B. He's the guy who would make really blunt Piazza posts. He's the one who responds really bluntly on Piazza. Okay, I don't know if he's doing Piazza this quarter, but in the past he would give like really blunt responses to Piazza, and everyone in TS 106B would know like, I'm scared of asking questions because Anand gives really blunt responses. Okay, so he's a really fun guy. He'll be coming in probably sometime next week. Okay, cool. Thanks for coming. If you want chocolate, come to the front and grab some. Hi. Oh yeah, of course.